In this chapter, we will be studying trigonometry. In this lesson, we're just going to take some time and do some extra practice questions. Okay, hi everybody. So in this video here, what we're going to do here is basically just do a bunch of extra practice. We're going to go through a bunch of trig problems, and I'm going to work them through with you, kind of explain my reasoning as I go through. And remember that what we want to do here is we want to identify all the right angle triangles. And anytime you look at a problem here, I want to make sure I can see where the right angle triangles are. I'm going to have to think about these in terms of my definitions of opposite and adjacent and hypotenuse so that I can apply my trig ratios properly. And remember, I'm also looking for that triangle. It's got those three pieces of information that I need. Once I've got that triangle with the 3 bits of information, I can find anything else about that triangle and then hopefully move on to the other triangles in the problem if need be. Anyway, hopefully after several examples of this, you're going to catch the flow of this, and these problems will be a lot easier for you. Okay, so in this question right here, I'm asked to find angle ABC. Now, it's been highlighted here, but just remember so that you make sense of how this works here. When I ask you for ABC, I mean I'm starting on vertex A, I slide over to B, slide down to C. The angle that I make is the angle that I'm looking at. So the vertex is going to be the letter in the middle. Okay, well here's my one right angle triangle, and I know it's a right angle triangle because that will be on both sides. That right angle here. Here's another one, but this one is giving me the 3 bits of information. I know it's a right angle triangle, I know this angle is 35, and I know that the hypotenuse here is 10. So let's focus our attention on this triangle. I don't have enough in this triangle, but I will get it, because what I'll do here is I'm going to find that common side here. So let's call this x. So x is going to be opposite the angle that I'm given. And I know that my 10 here is going to be the hypotenuse. So this is opposite, and this is hypotenuse. So think about what trig ratio that might be, opposite and hypotenuse. And I realize, okay, that's a sine ratio. So to start off with, I'm going to get the sine of 35 degrees is going to equal x, my opposite, over 10. And so now 10 multiplied by the sine of 35 degrees is going to be equal to x. Okay, so let's figure that out. 10 times the sine of 35. And to the nearest tenth, I get that to be 5.7. Okay, so I'll put that over here. 5.7, what is that, meters, roughly, approximately. So good. So now I know what x is. But remember, I'm trying to figure out what this angle is. So in this triangle now, this being the reference angle, I have the adjacent side, I have x now, and I gave you the hypotenuse. So what trig function puts together the adjacent and the hypotenuse? Well, I look at SOHCAHTOA, and it's going to be cosine. So the cosine of my angle ABC, is going to equal my adjacent, 5.7, divided by the hypotenuse, 12. Now, remember that it's the angle that I don't know here, so what I'm going to have to do here is use my inverse trig function, so that'll be the inverse cosine of 5.7 over 12. So go to my calculator here, and it's going to be the inverse cosine of, now I want to use the value here that I had calculated originally, so I'm going to go back up and grab that, 5.7, blah, 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 divided by 12. When I press enter, I get 61.446 and so on. So rounded to the nearest degree, that's going to be 61. So it's approximately 61 degrees. All right. For this next question, we read that from the shorter building, Sam finds the angle of elevation at the top of the second building to be 41. Now remember, that is going to be from the horizontal up. That's the angle of elevation. So this is going to be 41 degrees. And the angle of depression, and that's from the horizontal down, is going to be 54 degrees. And then the two buildings are 56 meters apart. And remember, that 56 okay, measured at the bottom, is going to be the same as the distance across here. So this is going to be 56 meters right here. Now, what we want to do is find the height of the second building here. Well, I've got the two right-angled triangles here. The height of the taller building can be broken up into two parts here. Let's call this part x and this part y. And so my height is going to be equal to x plus y. So now what I got to do is I got to find those parts. So let's look at the bottom triangle first here. Here's my reference angle. I have the adjacent, okay, that 56. And what I'm looking for is the opposite. So SOHCAHTOA. Which trig function puts opposite and adjacent together? Well, tangent. So the tangent of 54 degrees is going to equal the opposite, x, over the adjacent, 56. And I know I've said it before, but I love it when the unknown is up in the numerator, because now all I got to do is make it 56 times the tangent of 54 degrees is equal to x. So 56 multiplied by the tangent of 54, and it's approximately 77.1. Approximately. My triangle up here, you're going to notice, is very, very similar because I have the angle here. That's my reference angle. So that makes this my adjacent and the y is my opposite. Well, it's the same scenario, basically just flipped up here. So that's going to be the tangent of 41 degrees will equal y over 56. Again, multiply up. So 56 times the tangent of 41 degrees is equal to y. 56 multiplied by the tangent of 41. And I get 48.7 when I round it, 48.7. Okay, well, now to get the height, I'm just going to add those two together. So on my calculator, I'm going to go up and I'm going to grab that number, and I'm going to add to it the value that I just calculated. And I do it like this so that I don't make any rounding errors. And I get to the nearest, find the second to the nearest meter. To the nearest meter, that's going to be 126 meters. Okay, and there we go. It's a good question. This is a classic problem, finding the height of the building from another building. Okay. So our next question here says a police helicopter flies 100 meters above ground. Okay, let's label that here, 100 meters above ground. And it'll be perpendicular straight up here. From his position in the air, he notices two vehicles on the road in the distance. The angle of depression to the car, which has got to be this one right here, is 50. So that's my angle of depression. So it's going to be from the horizontal down. So that angle there is 50. I'm just ignoring this line to the truck here. It's just down to the car is 50. And the angle of depression to the truck is going to be 20. So what is the distance between the car and the truck? We want to know what this distance is right here. Let's call that x. Okay, well, I've got two right-angled triangles here. I've got this one that goes out to the truck and the one that goes down to the car here. But the angles that I'm given aren't inside those two here. But if this is 50 degrees, then this angle here must be 40 degrees, because this angle overall from the vertical to the horizontal has got to be 90 degrees. So if part of it is 50, then the other part here is going to be 40. The other angle here, if this is 20 degrees down to here, then this angle over here must be 70 degrees. Okay? Because, again, same reason, those two angles together must be 90 degrees. If I go from here and I rotate up 70, then it's going to take me another 20 degrees to get out to that horizontal line. Now, this creates for me two different triangles. So in the smaller case here, this is 110 meters. This is 40 degrees, and here's my 90. Now, what I'd like to do is find this distance. Let's call it y. Then I've got this larger triangle where this is still 110, but this angle now is 70 degrees, and I want to find this length here. So I want to find z, and I want to find y. And the reason I do is because I know that x is going to equal z, whoops, sorry, not equals y, z minus y. Okay, so now I got to look at my triangles here and see if I can grab the appropriate information. So this is 40 degrees. So the side that I'm looking for is opposite. The side that I have here is the adjacent. Well, that's tangent. The tangent of 40 degrees is going to equal the opposite over the adjacent. And because the unknown is up in the numerator, I can just multiply that out. 110 times the tangent of 40 is approximately going to equal y. So here we go. 110 times the tangent of 40. And to the nearest tenth, I get 92.3 meters. And again, that's approximate. Here, I have basically the same situation. The only thing that's changed here is the size of that angle. So it's still going to be tangent. It's going to be z over 110. So again, I can multiply that up. And so now 110 times the tangent of 70 degrees. In this case, 70 degrees. And I get 302.2. And that's approximately equal to z. So for me to now get the x value, I'm going to take z, 302.2, and subtract 92.3. Now on my calculator, I'm going to do it like this. I'm going to go up and grab 302.2, and I'm going to subtract, I'll go up again, 92.3. And I'm going to get that the answer is approximately 209.9 meters. Good. Okay, everybody, let's take a look at this next question here. Now, you should probably recognize that this question looks really similar to the one that we were just looking at with the police helicopter. It's just that now the information is given in a little slightly different way here. So I'm still looking for PQ. So if I call this X, call this Y, and call this whole side over here Z, I'm still going to go over here, and it's still going to be X is going to equal Z minus Y. Whoops, sorry, you can't quite see that. Now, what I'll do here is I'm going to break this up into the two different triangles. So first of all, I've got a triangle where this is 31 degrees, and here's 6.3. Now, I'm looking for Y. So because that's the angle I've chosen here, Y is my opposite. 6.3 is my adjacent. So that's, again, that's going to be tangent. So the tangent of 31 degrees will equal Y over 6.3. And then just like I've done a bunch of times before, I'm going to multiply that up. Bring over my calculator, and 6.3 multiplied by the tangent of 31 to the nearest tenth is going to be 3.8. Okay, that'll be centimeters. But now I've got this other triangle over here, and I'm looking for Z here. This is still 6.3, but now the angle's a little bit bigger. It's not 12. If I cover that triangle up here, notice that the 12 is not part of a right angle triangle. What I want to do here is put these two angles together and get 43. This is supposed to be 43 degrees right here. All together, that whole angle. But now, it's the same situation as before. I have the opposite. I'm looking for the opposite. I have the adjacent here. So the tangent of 43 degrees is going to equal Z over 6.3. So 6.3 times the tangent of 43 degrees is going to equal Z. So on my calculator, 6.3 tangent of 43. Okay, so it's roughly 5.9. But now to get the difference between them, I'm going to take that value that I got for Z, and I'm going to subtract the value that I got for Y there. And putting those together, I get to the nearest tenth, approximately 2.1 centimeters. Okay? And that's what I was looking for. All right, now in this problem, it's a similar sort of setup to the previous one, but notice in this case here, I'm still asking for this BC, for this little strip that's out here, but now I'm giving you slightly different information. what I'm giving you right now is you know the distance CD, you know the height here, but you also know this little angle, and it's just this little angle here. Now, that's not enough. I need to know what the entire side is here, and let's call this, again, let's call this Z, if I want to figure out what X is. So to figure out X, and I'd write this over here, let's say X is going to equal Z minus 4.9. So what I need to do is I need to figure out what I need to get a way of figuring out what Z is here. Now, to do that, I really need that whole angle. Well, because of this information here that I've got, I know that this is a right angle, and I know that this is 4.97.4. To look for this angle, well, I have the opposite, and I have the adjacent. Well, I can use tangent. Now, notice that 13, this is extra. Okay, I cover that up here. That's an extra piece that I'm going to add on later. But for right now, I know that the tangent, let's just call this theta. The tangent of theta will be 4.9 over 7.4. That's if you ignore this extra little bit, and I'm just looking at this triangle right here. To get theta, I will do the inverse tangent, because that's how I go from a ratio back to an angle. And so this will be the inverse tangent of 4.9 divided by 7.4. Okay, and I get 33.5. Okay, so approximately 33.5 degrees. But what I'm going to do then is going to add that to 13. So the angle BAD is going to equal what I just found plus 13 degrees. So 46.5. Approximately 46.5. That's wonderful, because now I've got this entire angle. I need to find the opposite side, and I have the adjacent. So now I can write that the tangent of angle BAD, which in this case was 46.5, will equal Z over the adjacent 7.4. So 7.4 times the tangent of 46.5 will equal Z. Okay, now, so over here, I will go 7.4 multiplied by the tangent of, now in this case, I'm going to go up and grab that angle that I found before. So I use as many decimal points as possible. Close the brackets, press enter, and I get that it's approximately equal to 7.8. So now I can write that X is approximately 7.8 minus 4.9. So if on my calculator here, I'll simply press subtract, because the calculator knows to subtract it from there. 4.9, and I'm going to get approximately 2.9 centimeters. Is that length for BC? Okay, everybody. Another question here. So in this case, I want to figure out what AD is. Okay, so I've got this right angle triangle right here. There's my angle 40, but I've only got the two angles here. I know that this is 90 degrees. I know that's 40. That's it. I do, however, have this other right angle triangle right here. And in this case, I've got 3 bits of information. I know this angle. I know that this angle is 30, and I know that this side is 18. Now, to make the transition over to this triangle, I need to find another bit of information here. Well, I'm not going to be able to find that angle, but I can find this side right here. The side AC is the hypotenuse of this little triangle here, and it becomes the leg of this triangle here. So this is what I want. Let's call that X. So in this smaller triangle here, with this as my given angle, I've got the adjacent side. I am looking for the hypotenuse. So what trig function puts together the adjacent and the hypotenuse? Well, the answer is cosine. So the cosine of 30 degrees is going to equal my adjacent 18 over x. Okay, well, my variable is in the denominator. That's not awesome, but I can just swap those two. So x is going to equal 18 divided by the cosine of 30. Then I go to my calculator. 18 divided by the cosine of 30. So to the nearest tenth is approximately 20.8. So approximately 20.8 And it looks like the units are meters. Good. So now I have this side right here. Now I know what x is. So in this triangle, I now know what the opposite side is, and I want AD, which is the hypotenuse. We'll call that y. Okay, so what trig function puts together the opposite and the hypotenuse? And the answer is sine. So the sine of 40 degrees is going to equal the opposite, which I just figured out was 20.8, over my adjacent here, over the hypotenuse, y. So the unknown is in the denominator, so y is going to equal 20.8 divided by the sine of 40. So I pull that out, go to my calculator. I've already got that in there, so I'm going to divide by the sine of 40. And I get that my answer is approximately 32.3 meters. Okay, so in this problem about triangles, we read that from the top of a cliff, 120 meters high, so that's this right here, an observer sees two boats, one directly behind the other. Okay, so that's these points right here. The angle of depression to the farther boat is going to be 27 degrees, so that's from the horizontal down, and to the closer boat is going to be 47 degrees. Okay, and so remember, those are the angles of depression, so they are from the horizontal down. And we want to find the distance between the two boats. That's the x here. So we've done problems like this before. So what we're going to do is we're going to find this distance out here. There's going to be our z, and we'll find this distance right here. We'll call that y. So what we want to get here is we know that x is going to be equal to z minus y. Now it's just a matter of finding those pieces. So let's take a look at this triangle here with the y in it first. So I know that this is 120. I know this is y. Now, the angle inside here is going to be, well, the angle from the horizontal down is 47. And I know that those two angles together have to add up to 90. So it's going to be 90 minus 47. So 43 degrees. So in here, this will be 43 degrees. Okay? So what I'm doing is I'm just ignoring this line over here, and I'm looking at this down to here is 47, so that means this over to here has to be 43. Together they are 90 degrees. Now in this triangle, if this is my reference angle, the opposite side is y here. That's what I'm looking for, and I gave you the adjacent. So that's the tangent. Tangent of 43 degrees is going to equal y over 120. So 120 multiplied by the tangent of 43 degrees will equal y. And that will be approximately 120 times the tangent of 43, 111.9. Approximately 111.9. Now, we look at the bigger triangle. Now, this angle up here, because this angle is 27, it's this angle that I'm interested in. So it's going to be 90 minus 27. It's the same kind of attack here. 90 minus 47, 90 minus 27. And that's going to get us 63 degrees inside there. I am looking for the side opposite the 63 degrees. That's my z. And once again, I have the side adjacent. And once again, that's going to be the tangent. So the tangent of 63 degrees will be z over 120. Multiply that up. 120 times the tangent of 63 degrees is equal to z. So 120 tangent of 63 is 235.5. Approximately. So now, over here, I can do 235.5 minus 111.9. Except when I do my calculator, I'm going to go up here, I'm going to grab that number, minus, and then I'm going to go way up here, grab that number, and let the calculator handle all that. And so I get 123.6. 123.6 meters is what we're looking for in that problem. All right, so in our last problem here, we read that the angle of elevation of the top of a tree Okay, so to the tree here is 27 degrees. So that's that little bit right there. And from the same point on the ground, the angle of elevation of a hawk is 43 degrees, and it's right above the tree, it looks like. Now, the tree is 12.7 meters tall. How high is the hawk above the tree? So we're looking for this distance right here. We'll call that x. Now, if you take a look, if you look at the picture that from the question above and look at this one right here, what I'm going to do is I'm just going to rotate the picture that I'm looking at right now and notice that it really is quite similar. It's the same question. So I'm going to approach it in basically the same way here. So I'm looking for z, and I've got my x there. So the height that I'm looking for, x, is going to be z minus the 12.7. So what I got to do is I got to figure out what the z is, what the whole distance is. Well, the only triangle that I've got 3 bits of information on is this one right here. Okay, I've got the 27 degrees. Remember that 43 is in the bigger triangle. So I've got the 27, and I have the side opposite it. Well, you know, it turns out the side adjacent, this QG here, that side adjacent, let's call that y, that's actually part of the big triangle as well. So if I just focus on that little triangle right now, where this is 27 degrees, this is 12.7, and we'll call this y here. Well, I've got the opposite. I'm looking for the adjacent here. That's tangent. So the tangent of 27 degrees is going to equal 12.7 over y. Because my unknown is in the denominator, what I can do here is swap those two, swap the trig function in that value. And so this will be 12.7 divided by the tangent of 27. Okay, and I get that y is approximately 24.9. So that's the bottom here. Now, in that larger triangle, where this is now 43 degrees, what I would like is the opposite side. What I just figured out was the adjacent side is 24.9. That is still tangent. So the tangent of 43 degrees is going to equal z over 24.9. In this case, though, I love the fact that the 24.9 is in the denominator, so I just multiply it up. And that will equal z. And so now 24.9 multiplied by the tangent of 43 is equal to 23.2. Okay. So now I've got z, so now I can come over here, and this is going to be approximately 23.2 minus 12.7. So I'll go up, grab 23.2 minus the 12.7. And to the nearest tenth of a meter, that hawk is approximately 10.5 meters above the tree.